Alright, here we go. Okay, so we got factoring review on our third lesson for pre-calc. We have 5-ish lessons here. I think there's a 3A, 3B, but so factoring, one thing that isn't reviewed for you guys that they kind of thrown as a review is this part, difference of cubes. You guys really haven't seen that before. So it's a pattern of when you're factoring difference in sums of cubes. So it's just a pattern. So you have a cubed minus b cubed works out to be like this. A cubed plus b cubed works out to be like this. You'd get that form. That's on your calc formula sheet if you need to break some type of difference of cubes down. Okay, so don't kind of get worried about that. You know the difference, like these ones up here are fine. And this right here is just the perfect square, right? Like the same exact thing multiplied is that pattern. We do that stuff in 20. Okay. All right, so just kind of going through this here, just the idea that, you know, don't forget, as we get harder in calculus, we need to be comfortable with radicals of different things. So like if you get x squared minus 8, well, I can't factor that. It's not a perfect square. Well, you could. You can call it a root 8 and a root 8, right? So you can make it so it's not a nice whole number and still work to your advantage. And we'll do that a little more in calc, makes us a little more flexible in what we're doing. Okay, so just kind of keep that in mind as well. All right, so let's do x cubed minus 27. So we're going to go right to the difference of cube form there at the top. Okay, so if you do that, that's going to be starting with x minus 3. So remember, you're taking the cube root of 27, which is 3. That's what the b is in this case. And then you're doing x squared plus 3x plus 9. And that's all you can do on that one by using the form above. Okay, if you're not sure where I got b is just the cube root of what 27 is. Because 27 is 3 cubed. Yep.
Wait, what is? Oh, wait, never mind.
Make sense?
Yeah, because 9 is just 3 squared, right?
Right. Yeah. Okay. All right, let's look at this one. Why don't you go ahead and try 8x cubed plus 125y cubed. So first thing is, when you do this, they need to be perfect cubes. 8 is, x is, 125 is, and y is, in this case. All right, so we're using the plus one, so the one to the right. So that means we're going to go 2x plus 5y. Okay, 4x squared. Why is it 4x squared? Because I'm squaring a 2 and an x. Minus 10xy plus 25y squared. Okay, take a second there, see if that makes sense. If there's any of those numbers I wrote down that you're not familiar with where I got it, just ask. Really kind of the key on those is identifying what A is and what B is. Okay, so A is 2x, B is 5y. Okay. All right, a couple other ones you should be familiar with here, a little bit easier ones actually. So you know your x squared minus 3x minus 18, that's just your inspection from Math 20 and Math 10. So combos of 18, difference of 3, that's going to be x minus 6, x plus 3. Okay, when we have, like this one here, you could do decomp if you want, but the one thing I noticed is I have a 25 and a 4. So those are both perfect squares. So this could be a perfect square factor. So to test that, I would write 5x plus, or sorry, it'd be 5x minus 2 times 5x minus 2, possibly. So what I'm going to do is 5x times 5x is 25x squared. Negative 2 times negative 2 is positive 4. So to test this, 5 times negative 2 is negative 10. Timesing that by 2 would be negative 20. So it is that. So it would work. So this thing simply it is 5x minus 2 squared. Now, if you're not good with those patterns, you can always use decomp. You can go 25 times 4, break it down through grouping. Same thing we've kind of done for a while. Okay. All right. Any questions on that one? Nope. Good. All right. So one more page here. Class example number 3. So we're going to factor this one. So we're going to do this quite a bit in calc. You have to be really good with fractional exponents because when we're doing derivatives and stuff, we're going to be changing our exponents a lot. And we'll kind of get to that. But see how this is 5 halves, 3 halves, and 1 half? This still, to us, we need to be comfortable, they have a common term. They have an x to the 1 half we can take out. Now, if we take out an x to the 1 half, it makes our life quite a bit easier. If you take a 1 half from a 5 halves, that's 4 halves, now it's an x squared. A 3 halves to 1, that's just a 202, which is just 3x. and the 1/2's gone, it's just a 2. So now it's way easier for us to see. So then it's to be x to the 1/2 times x plus 2, x plus 1. Okay. What do you think you would pull out for number 4? You started getting the habit of, I'll let you think about it, but you started getting the habit of what to pull out. So what would you pull out? Not quite. Not quite. So we take the negative 3/2 out. So whenever you're pulling stuff out, guys, we usually pull out the what? The smallest, right? If you have an x cubed, an x squared, and an x, what do you take out? You don't take an x cubed out. You take an x out. Well, same applies even with negatives. Take the smallest. Okay? So smallest is x to negative 3/2. So we're going to take x to negative 3/2. And when you do that, that's like you're adding those now, right? So if I took a negative 3/2 out, that 1/2 turns to 4/2. 1 plus 3, which is x squared. Do you want me to write 4/2 so you can see it? Or are you okay? I can write it. I'll write it so you can see it. So if I take the negative 3/2, I would add 3/2 to 1/2, which is 4/2. I would add 3/2 to negative 1/2, which is, that'd give me 2/2. And then this one would be all the way out. So it'd be there. So this is really just x squared plus 7x plus 12. So then your final would be that right there. Okay. All right. Factor this one. So I tried to group with this. I tried to move things around and factor. I couldn't do it. So what is our strategy for Math 30 if it's not factorable yet? Do synthetic division, right? So we're going to do synthetic division. So this is a case, guys, where we have no leads to what to try. So there's two things you can do. Okay, you can put this into your calculator and get an idea of a 0 to try. So if I give my calculator, oh, it's a 1, I'm going to try a 1 with synthetic division. Or you have this as your options. Remember, it's this over this for options. The factors of 3 over the factors of 2 are your options. So all combinations of 1/2, 3/2, 3/1, all those combinations are possible zeros. Okay? I'll kind of cut to the chase for you guys. If you went and looked, it looks like it's going through -1, so I'm going to try -1 first.
Going through 1 or negative?
-1. Like -1 is 0, so the factor be x plus 1, but -1 is the 0. Okay? So -1, so then we're going to go 2. If you forgot the synthetic division, if it's been a while, we'll refresh that here. So here's just the synthetic division. You drop the 2, you multiply, that's a -2. Add, -7. Multiply, 7. Add, 3. Multiply, -3. That means it is a factor, getting a 0. So that means if it's -1 to 0, that means that x plus 1 is a factor. So what's left is a quadratic. We can factor this. That's what's left. Because we lost a degree, right? When you synthetically divide, the quotient is 1 degree less. So that cube is now a square. That's why I went to a square. So now we factor this. 2 times 3 is 6. Factor of 6 is -7, is -1 and -6. I'm going to come up here to break this down. 2x squared minus 6x minus x plus 3. Yeah. Okay, and so we have that. We have 2x squared minus 6x. Pull the 2x out. Pull a -1 out. They match. We're happy. You have all your factors. You have a 2x minus 1 factor and an x minus 3 factor. Okay, questions on that one? Okay, So this one, it's a little bit more direct than it looks, but you have x plus 1 to 3 halves minus 2 times x plus 1 to the 1 half. Well, they have a common factor of x plus 1. And what's the smallest? The 1 half is. So we're going to pull an x plus 1 to the 1 half out. When I do that, if I take a 1 half out of a 3 halves, so off of it, that makes it x plus 1 to the 2 over 2, which is just 1, but I'll write 2 over 2 for now, just so you can see it. And then if I take this out, it's just a minus 2 here. Well, 2 over 2 is really nothing, so we're able to drop that and write it just x plus 1 minus 2. Because 2 over 2 is just to the 1, so there's really no exponent there. And now you're done, because you just got to finish that off. You're there. 1 minus 2 for x minus 1. So this is your final factor. Okay, stop there.